Hi, this is Ron Cipcic. In this particular segment, we're going to take a look at the general price level. The general price level is basically a measure of prices for an entire nation. It is impossible to express the general price level in terms of the currency of a country. For instance, in the United States, that currency would be dollars. There's no way to compare very, very expensive products with very, very inexpensive products. It's largely meaningless to take an average of the price of a house, for instance, in dollars and compare it to the price of a cup of coffee in dollars. That's, 1 unit of house and 1 unit of coffee. The house might be $250,000 and the coffee might be $2.50. Well, comparing those two prices or averaging them would be largely meaningless. It would be very distortive. So we have to come up with a measure of the general price level that captures the diversity of prices and the importance of some goods over other goods. And so what we're going to do in this particular lesson is take a look at how the general level of prices is actually measured. Now, before we dive into the actual measurement methods, let's just get a couple definitions out of the way. The term inflation represents a continual increase in the general level of prices. The word continual means we're not talking about a one-time increase in prices. We're talking about a year-to-year-to-year increase. So continual means year-to-year-to-year or long-run increase. General means most things are increasing in price. We're not implying that everything is increasing in price. A good example of this would be the United States with respect to computing. In the United States, we've seen the general level of prices move upward since World War II. There have been a few periods where prices have dropped a little bit, but basically the general level of prices have moved up almost every year since World War II. Some years a lot, some years not so much, some years somewhere in between. However, if you look at computing power and you look at things like, computers or handheld, smartphones, things like that, you'll see that the price of computing power has actually been decreasing fairly quickly over the last, let's say, 50 years. So computers are a very important part. Computers and computer technology are a very important part of the U.S. economy, and yet those prices have dropped while the general price level has actually increased, which means some things must increase in price faster than other things, and some things actually drop in price while most other things are actually increasing in price. So that's important to acknowledge. Now there's a second definition called deflation that I'd like you to pay attention to, and in the case of deflation, you have just the opposite. You have a continual decrease in the general level of prices. And this is quite unusual. We haven't seen this in the United States. We saw it a little bit here in the Great Recession of 2007 to 2009. I'll actually show you some data today where even recently we might begin to think that there has been some deflation or near deflation in the U.S. economy. But really the period you want to think about when you think about deflation would be the Great Depression. Between 1929 and 1933, the general level of prices in the United States decreased over 25%. So that was a significant decrease in the general level of prices. Now you might think, wow, that's really good. That isn't a problem. That's really a blessing. But that is actually not true. During deflationary periods, you're going to see falling asset prices. You'll see land prices falling. So people will have bought homes and other types of real estate at a relatively high price, and they'll see the prices of those assets decreasing. Generally, in a period of deflation, it's very difficult for businesses to improve their revenues and profits. So it's more likely that we'll see layoffs and slow economic activity. Very difficult for wages to increase during deflationary periods. So deflation is generally considered to be an economic problem when it really sets in. And so the ideal situation at the general level would be neither price increases nor price decreases, which would be basically the average level of prices staying constant over time. And of course this rarely, if ever, happens. All right, so the next thing we want to do is we want to actually dive in and we want to talk about what do we mean by the general level of prices. I mean, what is this actually talking about, and how is this actually measured? So let's go ahead and move right into this. Now what I've done is I've set up a table here, and why don't you take a minute and draw this table, and I'm going to basically fill in what is open here in the table. Notice what I've done is I've set up 4 hypothetical years, 20x1 through 20x4, and I've established what are called basket values for each of those years. Now let me explain what we mean by the term basket. The term basket has a very specific meaning here. When the government goes out to measure the general price level, one way it does it is it identifies a basket or group of goods that it's going to track. All right, and the government's going to ask itself, what do typical buyers buy? So for instance, do typical buyers buy toothpaste? The answer to that is yes. Now obviously there are probably a few people who don't use it, but most people use it. Some use it more than others, but in fact you would expect that something like toothpaste would be in some basket that expresses the preferences of consumers. You'd expect that food items would be in there, and clothing items, and transportation items could even be in there, things like automobiles. Of course, if we put automobiles in the basket, we would have to weight automobiles more heavily. Obviously, a price movement in automobiles is very different than a price movement in toothpaste. A 10% movement in toothpaste is different from a 10% movement in automobiles, price movement. So there's all sorts of weighting that needs to be done, but the basic idea is that the government's going to go out and identify a group of goods that people typically buy, and it's going to weight that basket on the basis of the nature of those goods, and we're going to arrive at some sort of basket value. That process is quite complicated, and it's well beyond the scope of this lesson. So I'm going to actually give us the basket values, and I'm going to use very simple numbers here, very small and simple numbers. So in year 1 the basket value is 75, then it rises to 95, 110, and 115. So we can see that the basket value is actually increasing over this 4-year time period, and that indicates to us that the general level of prices has increased. You go, well, how do I know that? Well, we've held the quantities or the weights in the basket constant. So we assume that the quantity of toothpaste or the quantity of automobiles or whatever's in the basket, we hold the weights and the quantities constant. So the only thing that can explain the basket increasing in value, the only thing that can explain the basket increasing in value would be increases in prices. Okay? Now that doesn't mean everything in the basket is increasing in price, but there must be enough movement in the prices of those basket items upward to pull the entire basket value upward. Now a second important idea here is to identify one of the years as our base year. We're going to identify arbitrarily. Arbitrarily means it's picked. I could pick any one of these 4 years here, but I'm going to identify 20x2 as what we call our base year. Now what that means is the other years are going to be compared to 20x2. Now let me get this blue marker out of here, and this gives me a chance to use my fancy smancy erasing tool, which I always love to use. Okay, anyway, back to our regular programming. So what we're going to do here is we're going to compare 20x1 to 20x2. We're going to compare 20x3 back to 20x2, and we're going to compare or anchor 20x4 back to 20x2. So all of the years, no matter how far we go forward or how far we go back, all of the years will be anchored or referenced to one year. That year will be called the base year. And again, it's arbitrary. You'll see, well actually I won't prove it, but you could actually prove it, that it doesn't really matter in relative terms what year you pick. What we're looking at is how the other years relate to the year in question, And the relationship between years is really a constant, if you think about it, in terms of percentage terms, whichever base year you pick. Okay, so let's just not worry about that. We're going to select 20x2 as our base year, and then we're going to base all of our calculations off of that. Okay, now the idea is to calculate something called a price index. And I'm going to move up to the top here. I've left myself some room above where we started to make these calculations. So let me identify how you calculate what is called a price index. Now, the price index, let's say for year 1, is equal to the current basket value, current basket value divided by the base year basket value, and then that's a ratio. Then we're going to multiply that ratio by 100. So for year 1, price index 1, what's the value of the basket in the base year? Well, if you go back down to the table, you'll see the basket value in year 1 is 75. We divide that or compare that to 95, which is the base year value of the basket. We take that ratio and we multiply it by 100. Now what that's going to turn out to be is, if you actually go ahead and calculate, that's going to be 0.789, I've rounded that off, times 100. So our basket value is actually 78.9. Okay, if we've done that correctly, we'll get 78.9. Alright? So what we're going to do is we're going to come back down here and we're going to plug that in to our table. So this will be 78.9. Okay? Now let's go ahead and do a couple more of these, and then we'll go ahead and fill our table in. Let me just go ahead and use this open space up here at the top. We've got some open space up here. I apologize for this scrolling tool. It's kind of a weird scrolling tool, but it does require me to be very skilled in the use of this piece of software. All right, now, how do we get price index? How do we get price index for year 2? Take the price index of year 2. We get the price index of year 2 by what? By dividing the current value of the basket, which is what? 95, by the base year value of the basket, 95. You go, that's nothing very interesting. It isn't, but it's going to show an interesting result. The interesting result is the index number is always what in the base year? Well, this is 1 times 100. So the index number in the base year is always 100. The index number in the base year is always 100, even on exams. Even on exams. Figure that. Let's do another one here. Let's do one more time. So PI3, we're actually going upwards. That's interesting. So what's the basket value in year 3? Well, the basket value in year 3 is 110. We divide that by what? The base year value of the basket, 95. We multiply that by 100. I just happen to have that number handy. That would be 1.158. We multiply that by 100. Multiply that by 100, and we get 115.8. Okay? Alright, so that gives us the idea. Current basket value divided by the base year basket value times 100. So let me go ahead and scroll down. And we'll go ahead and fill in our table because we have lots more we want to do with this. Okay? Are you having fun yet? Do you have your calculator with you? Whenever you're working in macroeconomics, you need a calculator because macroeconomic ideas are expressed numerically, almost always. And again, math is a very, very powerful language. It's a common language around the world. And if we can express things mathematically, these numbers can be understood by anyone in the world. So that's kind of a cool thing. So let's put our index numbers in. So let me go back to green. And we have 78.9 here, 100 here. We said that this one would be 115.8. And if you went ahead and calculated the next year, I just happen to have that ready, 121.1. Now I'm rounding off here. You can see that actually, if you look at the real data, if you look at Bureau of Labor Statistics Consumer Price Index data, you'll see these are actually carried out to 3 places. But we do not need that level of precision. Okay? We just don't need it. All right. Now, here's the next question. The next question is, how do you use price index data to get an inflation rate? That's the next question. Okay? So again, I'm going to try to use up some of this white space around us here. So how do you calculate an inflation rate from price index data? Let me go ahead and scroll up here, and I'll try to use up some of this white space if we've got some left up here. Okay, I'm going to actually do all the calculations and then we'll plug them in. Okay, so when we go from, in fact, let me just write the numbers across the top here. I think it'll be helpful if I do this. If we go from 20x1 to 20x2 to 20x3 to 20x4, our index data goes what? It goes 78.9, this is the price index, to 100, to 115.8, to 121.1. Now, you can see this index data is kind of nice because, again, everything year 1, year 3, and year 4 are all referenced to year 2, and now year 2 is expressed in hundreds. So it's very easy to see how each year compares to the base year. For instance, in 20x4, you can see that prices have gone up about 21% between x2 and x4. You can see it. We go from 100 to 121.1. That tells us that prices have gone up about 21% between those two years. So index numbers give us a very, very nice and clean comparison between years prior to the base year and years post or after the base year. Now we want to use this data to calculate an inflation rate. How do you do that? What you're going to do is you're going to take the percentage change. This is percentage sign delta. Delta it means change in. It's a Greek symbol for change in. So we're going to take the percentage change in the price index. Okay? So what we're doing is we're going to take the percentage change, which is the change, 100.0 minus 78.9 divided by, be careful, 78.9. So you take the change in the index divided by where you started. And that number, I just happen to have that, equals 26.7%. So the inflation rate between x1 and x2 is 26.7%. Very, very high by U.S. standards. Very high. If inflation were now running at an annual rate of 25% in the United States, Washington, and it's all they'd be talking about in Washington. And there'd be deep and very strong criticism of the president over this, even though presidents have nothing to do, almost nothing to do with inflation. President Obama, who is currently the president when this video is being done, would be blamed for inflation, particularly by Republicans. And 26.7% inflation in the United States is not acceptable. Now, if you're talking about Zimbabwe 5 or 6 years ago, 26.7% inflation would be very, very low. Zimbabwe had hyperinflation, where the inflation rate was in the millions of percent. You go, oh no, you got to be kidding me. Oh yes, Germany after World War I, inflation rates in the millions of percent. So 26.7% would have been a small increase in prices in Germany after World War I. We've seen countries have hyperinflation rates that are astronomical. So it's all relative. In the United States, inflation is a relatively small problem, at least relative to the rest of the world. And so this number by U.S. standards is very high, but by other country standards it could be relatively modest. Okay? All right, let me move on. 115.8 minus 100, we're going between where? We're going between, this calculation was between year 1 and year 2. Now we're going between year 2 and year 3. So I'm over here. So I take 115.8, this is really P2, this is the new price. I subtract P1, 100, and divide by 100. That's an easy calculation. We know that that's going to be what? Plus 15.8%. Still high by U.S. standards, but coming down. And then if we want the inflation rate between year 3 and year 4, it's going to be 121.1 minus 115.8 divided by 115.8. And again, I just happen to have that. That equals an inflation rate of about 4.6%. Actually still high by U.S. standards. Still high by U.S. standards. If inflation right now were about 5%, people in Washington would be talking about it. It would actually be an issue. Again, by other country standards, that's a relatively low inflation rate. So what we see here is we see that actually inflation is dropping. Prices are increasing across this spectrum. Between 2001 and 2004, prices are increasing in general, but they're increasing at a decreasing rate. This has actually got a name. This is called disinflation. Disinflation is a type of inflation. So here we have a period when inflation rates are decreasing. So essentially, if the math here would be prices are increasing at a decreasing rate. So if prices are increasing at a decreasing rate, then the inflation rates are getting what? Progressively smaller. It's like a car approaching a stop sign. The car is still moving forward, but it's moving forward at a slower and slower speed. It's decelerating. So prices are increasing, but they're decelerating. That's the idea. Okay, so let me just write this again. I want to make sure that you've got the idea. So the inflation rate is P2 minus P1 divided by P1, which is what? The percentage change in the price index. Okay? All right, that's how you calculate these inflation rates. So let's go ahead and go back down and plug these into our table, and we will have completed our table. And then I want to actually do a little bit more with you on inflation rates and how you can use price index data to do some other interesting things. Okay, so let's go ahead and plug our numbers in here. I'll use the same color. Now I'm going to actually plug these in between the two lines. So you can see I've got little arrows in here, and they're between because I need two price indexes. I need two price indexes to get an inflation rate. Okay, so the inflation rate here is 26.7%. Again, that's a plus. 15.8%. That's a plus. And then 4.6%. So you can see it in the data. The basket value is increasing, but you can see it's decelerating. It's increasing at a decreasing rate, and that's reflected here in these percentage changes. Remember, disinflation is inflation, but it's decreasing inflation. Disinflation is not deflation. Deflation would be where prices are actually decreasing, where these would be negatives, not positives. Okay, all right, so you need two basket values to get an index, and you need two index numbers to get an inflation rate. All right, now let's mess around with this a little bit more. There's a couple other things I want to show you here, and then we'll call it a lesson. This lesson's going on a little bit long here, but let's go ahead and finish this up on this particular segment. And let me show you some actual data for the United States. This is called the Consumer Price Index, and as the term would suggest, it's based on a basket of consumer goods that only consumers buy. And it again assumes that you have fixed weights or fixed quantities in the basket. So I'm looking at 2014, and I'm going to just put some data across here. Here's October, here's November. You know, better than doing that, let me go ahead and let me just go ahead and do it this way. I'm gonna erase this. I'm gonna do it this way. I'm gonna be more efficient here with my. So October, get my marker, October, November, December, and I'm going to compare 2 years actually. So I'll actually set them up in a table here. I was just going to sketch them out a different way, but let's just do it this way. So here's, this is CPI data. Of course, this is USA. And here are actual index numbers taken for 2013, 2014. So the last 3 months of these 2 years. Now, actually, at the time of this lesson, the last piece of data is the December 2014 number. We're currently in February of 2015, but the numbers lag. Like the January number doesn't come out till late in the following month, so the January number isn't out yet. And so the latest data I have is December of 2014. All right, so this is going to be 233.5. This is going to be 233.1. This is going to be 233. So you see that prices are basically falling the last 3 months of 2013. Now this is not unusual. This might be a seasonal, it could be something seasonal about this. This is nothing to get too excited about. Looking month to month to month is it's these short time intervals. People don't get too worked up. Okay, so I'm going to put the other ones in here. 237. This is 2014. 237.4. This is 236.2, and this is 234.8. And again, we see that over these 3 months, the price index, the monthly price index numbers drop. Okay, and again, there isn't, we don't want to make a lot of that. That could be seasonal factors. The data is often seasonalized, but there can still be kind of trends in the data that are seasonal in nature, and that isn't something to concern ourselves too much with. Now, what's interesting here is if we look October to October, we effectively have the latest inflation rates. For instance, here, at the time of this writing, this is the latest possible inflation calculation, because we can go December to December. The last monthly number is 234.8. So we can actually go 234.8 back a year to 233 and see what prices did in the last year. Okay, and that's a fairly easy calculation. Take 234.8, subtract 233, and then divide by what? Divide by 233. And if you actually do that calculation, I get plus 0.8%, okay, which is a very, very low inflation rate. That's less than 1%. Okay, if we do that here, the same process here, we get plus 1.3%. Just verify that number. Take some time and verify that number after you're off the video. See if you can actually calculate that. And then if we do this number here, 237.4 minus 233.5 divided by 233.5, we actually get plus 1.7%. So it's kind of interesting that year to year, the October change was 1.7, year to year the November change was 1.3, and year to year the December change was 0.8%. Now this is not the seasonal movement, okay? This is actually year to year, right? So this is indicating that inflation, as we move across the spectrum, inflation is actually dropping. And this is inflation, but it's actually again called what? Disinflation. Disinflation moving towards deflation, it looks like. We'll have to wait and see what this coming year holds, 2015. Okay, so you should be able to take two index numbers that you get from the Bureau of Labor Statistics website. If I were to ask you to go there to the U.S. Bureau of Labor Statistics website, and you can find index data like this, and you should be able to take a couple index numbers and actually make these kinds of calculations. Okay, I want to show you one other thing while we're messing around with index numbers. So let me go ahead and move this down, and I hope I have enough room to show you this. Well, not much room. We'll have to move this off to the side. We'll get rid of this, and let me show you another thing. This might be of interest to you. What's gone on with the minimum wage over the history of the United States? Well, that's an interesting question. I just happened to bring some data with me. Back in, let me just set up a little table here, and I'm going to go to a different color here. So let's just go ahead and divide that off, and then we'll go to a different color. Whoops, sorry about that. Well, we're having some technical difficulty. There we go. We're back. This is live. All sorts of bad stuff can happen. All right. So here's 1993, and we were going to use a different color, weren't we? Well, let's just keep with it. Here's 2003, and here's 2013. And let me show you something. So here's the minimum wage. We're going to call this the nominal minimum wage. And what happened over the last 20 years with the nominal minimum wage? Well, it went from what? It went from $4.25 to $5.15 up to $7.25. Okay, so it looks like it's what? It looks like it's increased rather dramatically over that 20-year period. Okay, I mean that looks like almost a what? It looks almost like a 75% increase. Okay, but in fact you cannot compare $1.93 to 2003 to 2013 if there has been inflation. Because $1.93 does not equal the purchasing power of $1 in 2013. They do not have the same purchasing power. So you can't compare them. People do it all the time. But once you're trained in economics, you never do it. You never compare nominal data. Nominal means in current dollars. You never compare nominal data over time when there's been inflation. You need to adjust the data for inflation. So what do we use to adjust the data for inflation. We can use a price index. So I'm going to use the CPI. And I just happen to have these data, the CPI for these years, 144.5, 184, and 233. Now, how do you adjust nominal data into real data? Okay? In other words, how do you use these index numbers to get the nominal data comparable? All right. You basically have to, I run out of room. I should have made a bigger canvas. I'm just going to use this area up here, and I'm going to change my color to this. Use blue. If you take a nominal dollar amount and you divide it by the price index, you get what we call the real dollar amount. The nominal amount is in current dollars. The real amount is in base year dollars. Okay? Once I get all of the data into base year dollars, I can compare them. So you go, well, what is the base year here? You don't have to know what the base year is. Now, the actual base year is actually 1982-84. It's actually a 3-year base year period. They used a 3-year period for this data stream. So 1982 to 84 is an index number of 100. So we can see these index numbers are all greater than 100 because 93, 03, 13, these years are all after 82, 84, so you'd expect the index numbers to be higher. What we do then is we're going to take the nominal amount and we're going to divide it by the CPI, and then we're going to calculate the real amount. Now, there's one little trick you have to be careful of. When you go to use the index number, you have to move the decimal point 2 places back to the left. Remember, when you calculated an index number, remember for my table, you multiplied the ratio by 100. So these numbers are expressed in 100. You need to get them back to their true numeric value. So this is really 1.445. This is 1.840. And this is what? 2.330. Okay? So index numbers are expressed in hundreds when you read them in the government data, but you have to know to adjust them back. All right? So let's get the real wage for each of these years. Okay? The real wage is in 1982-84 dollars because we know that 1982-84 equals 100. That's the base year period. You don't even have to know that. You just know that when you divide nominal data by the price index, whatever the base year of the price index, it's going to get you into real dollars. So if you divide 425 by 1.445, what do you get? I just happen to have that. You get $2. Excuse me, you get $2.94. So what is that saying? $2.94 in 1982-84 dollars had the same purchasing power as $4.25 in 93 dollars. So $2.94 in 82-84 has the same purchasing power as $4.25 in 93. Let's do it again. 515 divided by what? Divided by 1.840 equals what? Equals, I just happen to have that, be ready for a surprise, $2.80. So $2.80 is the equivalent purchasing power in 82-84 to having 515 in 2003. Now, these can be compared. These can be compared. Why? Because they're in the same year. Let's do it one more time. $7.25, which is still the current minimum wage at the time of this production, divided by 2.33 equals $3.11. So a slight increase in the minimum wage in real dollars. So you can see here as we move from 93 to 2003, the minimum wage actually decreases in real dollars. Adjusted for inflation, the real minimum wage actually fell over this 10-year period. Between 2003 and 2013, the minimum wage went up slightly over that time period. Basically, the increase in the minimum wage exceeded the increase in prices, so the real minimum wage increased slightly. It wasn't a big increase, but it was an increase. So what we see is we can use price index data. We can use price index data to what? To adjust nominal data to real data. And that's one of the most important uses of price index data. So let me very quickly review. I want to wrap this lesson up. We've already gone on quite a long time. You can first of all, to measure the general price level, you have to calculate a price index. Once you get a price index, that's going to give you a nice, clear comparison between a current year and base year prices. Okay? You can use that price index number also to calculate inflation rates, and we showed you how to do that earlier. Plus, you can take that index number and you can use it to adjust nominal data to real data. Okay? Again, you can get this price data at a website like the Bureau of Labor Statistics, the U.S. Bureau of Labor Statistics. In fact, the U.S. Bureau of Labor Statistics actually produces the data, so you can get it directly at their website, but many other websites actually take the data and put it on their websites. So this data is readily available for anyone who would like to actually know it and to actually play with it. Okay? Have a good day.